Good morning, everyone, and welcome back to the morning show. It is time for our Wednesday WHYS Guy, and we are testing out resonance this morning, I hear.
Right. So ultimately, we're going to work our way up to trying to break a glass with sound.
Okay.
And so the key to doing that is to understand that every object has one or sometimes more than one frequency that it likes to oscillate at. And I'll give you a simple example of that. Just this bowling ball hanging on a wire, okay, it oscillates back and forth. And if we want this oscillation to get bigger, it's like pushing a kid on a swing. You know that you're going to push it.
Right, a little more force.
A little bit every time, but it's very important that you push it at the right time. Right? If I push it when it's all the way back here, then the swing gets a little higher every single time. If I try to push it when it's there, it's just going to slow it down.
So it's got to be consistent.
So it has to happen at the frequency that the thing oscillates at. You have to provide the energy at the same frequency. Okay. Now, how do we figure out what the frequencies are for other objects that they like to oscillate at? And so there's some general rules we can look at. For objects, the pendulum is kind of the length, the size of the pendulum is kind of the length of the wire. Okay. So this is a very long when it's attached in the ceiling, so it takes quite a long time for it to go back and forth.
Okay.
These are just hanging from little tiny strings, and you can see that they oscillate faster. Okay, and in fact, the period of a pendulum only depends on the length of it. It doesn't really depend on whether it's a big fat ball at the end or a little one.
So it doesn't depend on the size or the weight at all?
It doesn't depend on the weight, but it does depend on the length.
Okay.
So smaller things tend to oscillate faster, bigger things tend to oscillate slower. That's kind of how you can look at it.
Okay.
Now, some objects you can think of as being sort of springy, okay? So here I have a spring and I have a mass, and if I just hang this mass on the spring, it oscillates at a certain frequency too.
Okay.
Now, how does this tend to go? If I put a stiffer spring on this, like this one is just fatter with fatter coils, okay?
Not going to go as far, huh?
No, but what do you think is going to go faster or slower, like in this period? Actually, it takes less time to go up and down now. The frequency is bigger.
Okay.
So the stiffer the spring, the faster it goes up and down. Okay?
Okay.
The more massive it is, if I use the same spring and I put lots more weight on here, then it takes longer again. Okay?
Very cool.
So the rule kind of is that if it's stiffer, the frequency is higher. If it's sloppy, the frequency is lower.
Now, how does this go into our breaking glass making here?
Okay, so now, glasses have a frequency they like to oscillate at too. If you just pick a glass up and ting it, it makes a sound, and that sound is because the glass is vibrating at its natural frequency. This is kind of thick glass. It's like a stiff spring. It's a higher frequency. This glass is very dainty. It's a lower sound, lower frequency.
Well, we're going to talk about all of this coming up. We have 2 more segments for you. We're having a fun day today, so stay with us. Right after this break, we're going to have a lot more when we come back, breaking some glass too.